Then next we are going to see about the abbreviation for solid principles. In this, the S stands for single responsibility principle, and the O stands for open close principle, L stands for risk of substitution principle, and I stands for interface segregation principle, and D stands for dependency inversion principle. Let us see them one by one briefly. The first one we are going to see about a single responsibility principle. In SRP context, responsibility can be defined as a reason to change when the requirements of the project modify. The modification will be visible through the alternation of the responsibilities of the classes. The responsibility will imply modification of the other responsibilities of the classes. This correction leads to a fragile design. Let us see a quick example for SRP. In this Java program, we declared a class as a phone. In this, a public void dial was declared as constant and a string number. Then a public void was declared as hang up and send constant string and message. And then finally, we declared public receive for constant string and message. The next we are going to see about open close principle. When a single modification of the software module results in the necessity of to modify a necessary of other modules, the design suffers from the rigidity. There will be no longer procedure modification on the existing code which already function. Instead, it will only require adding new modules. This is the special modification for open close principle. Let us see the example of them. In this example, the class and the server was connected between the interface called users. If in the future one wishes to use another type of server, all needs to be done is to implement a new class derived from the client interface class, but this time the client doesn't need to modify it. This is a perfect example of OCP. Next we are going to see about list curve substitution principle, which was known as LSP. In this language such as C++ or Java, the main mechanism through which abstraction and the polymorphism is done in inheritance. In order to create a correct inheritance hierarchy, we must make sure that the derived class extended without replacing the functionalities of the base class. Concretely, the new classes may produce undesired outcomes when they are used in the entities of the already existing program. This is known as LSP. This is the example for LSP. In this, the public class are set as set size and get size, and in private we are declared double M size. This is the example. And then next we are going to see about the interface segregation principle. In this, the classes implementing the interface will have to implement those methods also. In this method, one must be careful to put only those methods which are specified to the client in the interface. This is the main reason to get into the interface segregation principle. Let us see the example of ISP. In this, the class was declared as timer. In the public, we are declared the void registration, and then we declared a second class known as a time client, and then public was declared as timeout. This is the example of ISP. Last, we are going to see about dependency inversion principle. This principle indicates the fact that the high level modules must be independent of those lower levels. This decoupling done by introducing an abstraction level between the classes forming a higher hierarchy level and those forming a lower hierarchy levels. This is known as the dependency inversion principle. Let us see an example of dependency inversion principle. In this diagram, we clearly explains the dependency inversion principle. In those, the policy layer and the utility layer was interfaced between a mechanism layer. That's all about the types of agile property. Hope you like this video. Thanks for watching.